Imagine a world where machines can create art, music, and literature all on their own, where creativity is no longer exclusive to human beings, rather can be mimicked by machines. This is the world of generative AI, a powerful tool for creating new content. Yeah, from images to text, generative AI has come a long way in its fascinating drive, unlocking new possibilities for businesses, artists, and even governments. Today, we'll take a closer look at the history of generative AI and explore its intriguing evolution from the groundbreaking GAN to the highly anticipated GPT-4. For your convenience, we've added the link to the source of each generative model in the video description, so check it out and let's get started. The history of generative AI that we know today dates back to the early 2000s when researchers began experimenting with neural networks to generate images. Some raw forms like hidden Markov models or HMMs and Gaussian mixture models or GMMs were developed even earlier back in the 1950s. These models could only generate sequential data such as speech and time series. However, it wasn't until the development of the Generative Adversarial Network or GAN by Ian Goodfellow and his team in 2014 that generative AI really took off. But before getting into the chronological order for the generative models, let's briefly see the three main categories of the generative models. At first, we have the natural language processing or NLP. Well, NLP is a subfield of artificial intelligence that focuses on giving computers the ability to understand and interpret human language, both spoken and written. It combines various technologies such as computational linguistics, statistical models, machine learning, and deep learning models to process and analyze language in a way that is similar to human understanding. Key steps include tokenization, part-of-speech tagging, parsing, named entity recognition, sentiment analysis, and machine translation. NLP powers a variety of applications such as language translation, voice-activated GPS systems, speech-to-text dictation software, chatbots, and digital assistants. However, it's also increasingly used in enterprise solutions for streamlined business operations, increase employee productivity, and simplify critical business processes. Then comes the computer vision or CV. In computer vision, traditional image generation methods, in fact, relied on texture synthesis and mapping techniques. These methods used hand-designed features and had limitations in generating complex and diverse images. Other methods like Variational Autoencoders or VAEs and Diffusion generative models have also been developed to allow for more fine-grained control over the image generation process and the ability to produce high-quality images. Finally, let's see the transformers. Generative models in different areas have followed different paths, but eventually they intersected with a transformer architecture. The transformer architecture has become the backbone for many generative models in various domains, offering advantages over previous building blocks like LSTM and GRU. This architecture has been applied to NLP, resulting in large language models like BERT and GPT. Moreover, in computer vision, vision transformers and SWIN transformers have combined transformer architecture with visual components, allowing them to be applied to image-based tasks. Transformers have also enabled models from different fields to be fused for multimodal tasks, like CLIP, which combines vision and language to generate text and image data. Getting further with discussing the history of generative models in chronological order, let's get started with NGRAM. NGRAM is a natural language processing model developed in the 1960s and 1970s. It is a statistical language model that finds application in various NLP tasks such as speech recognition, text prediction, and machine translation. The model is trained on a corpus of text data by analyzing the frequency of word sequences and subsequently using this information to estimate probabilities. By employing this method, the model can predict the probability of a particular sequence of words in a given context. Then comes the long short-term memory or LSTM. LSTM was released in 1997 and falls under the category of natural language processing. It was specifically designed to overcome the challenge of learning long-term dependencies in sequence prediction tasks. LSTM is a recurrent neural network that stands out from other neural network architectures due to its ability to process entire sequences of data rather than just individual data points such as images. This is made possible through the inclusion of feedback connections within the network. Variational Autoencoders, or VAEs. Variational autoencoders were introduced in 2013 as a type of generative model within the field of computer vision. VAEs are able to learn how to compress large amounts of data into a smaller representation, which can then be used to generate new samples that resemble the original data. In simple terms, VAEs have the ability to create new data that appears to have come from the same distribution as the original dataset. This makes them incredibly useful for generating synthetic data for a wide range of applications. Gated Recurrent Unit, or GRU. The Gated Recurrent Unit, or GRU, was developed in 2014 within the realm of natural language processing. It serves as a more streamlined alternative to the LSTM network and is capable of processing sequential data such as text, speech, and time series data. What sets the GRU apart is its use of gating mechanisms, which enable the network to selectively update its hidden state at each time step. This unique feature of the GRU makes it a powerful tool for tasks that involve sequential data processing. ShoTel. The ShoTel model, which emerged in 2014, is a type of deep learning-based generative model that falls under the category of vision language or multimodal applications. This innovative model incorporates a recurrent neural network architecture and makes use of both computer vision and machine translation techniques in order to generate descriptions of images that are similar to those that a human might produce. By combining these different techniques, the ShoTel model is able to produce highly detailed and accurate descriptions that can be used in a variety of applications. Generative Adversarial Network, or GAN. Generative Adversarial Network was first introduced in 2014 as a type of generative model within the field of computer vision. GANs have the remarkable ability to create new data points that resemble the training data. This is accomplished through the use of two separate models, a generator and a discriminator. The generator is responsible for producing a fake sample, while the discriminator takes the sample as input and determines whether it's fake or a real sample from the domain. One of the most impressive aspects of GANs is their ability to generate highly realistic images that resemble photographs of human faces, despite the fact that these faces do not correspond to any actual individuals. This makes GANs an incredibly useful tool for a wide range of applications, from art and entertainment to medical imaging and more. Stack-GAN. Stack-GAN was introduced in 2016 within the field of vision language applications. This innovative model has the ability to generate highly realistic images based on textual descriptions. To achieve this, Stack-GAN employs a two-stage process. In the first stage, a low-resolution image is produced based on the given text description. Then, in the second stage, the image quality is significantly improved, with further details added to produce a high-resolution, high-realistic image. This is accomplished by stacking two separate GANs together. By utilizing this advanced two-stage process, Stack-GAN is able to generate highly detailed and accurate images that closely match the given textual descriptions. StyleNET. StyleNET was introduced in 2017 as a groundbreaking framework within the field of vision language applications. This innovative approach addresses the challenging tasks of generating captivating captions for both images and videos. While also incorporating different styles, StyleNET is based on a deep learning architecture that uses a neural network to learn the complex relationship between visual features and natural language captions. Specifically, the framework focuses on generating captions that closely match the style of the input visual content, resulting in highly engaging and visually appealing outputs. With its advanced capabilities, StyleNET has the potential to revolutionize the field of multimedia content generation and enhance the user experience across a wide range of applications. Vector Quantized-Variational Autoencoder, or VQ-VAE. In 2017, the VQ-VAE was introduced as a highly innovative generative model within the field of vision language applications. Unlike traditional variational autoencoders, the VQ-Variational Autoencoders aims to learn highly useful representations without any supervision. This is accomplished through two key differences. Firstly, the encoder network produces discrete codes instead of continuous ones. And secondly, the prior is learned rather than being fixed. Despite its simplicity, this model is highly effective and holds tremendous promise for addressing the challenge of unsupervised learning, which is a crucial problem in the field of deep learning. With its advanced capabilities, the VQ-VAE has the potential to revolutionize the way we approach unsupervised learning and enable new breakthroughs in a wide range of applications. In 2017, a deep learning-based model architecture called transformers was introduced to the field of natural language processing. These networks possess the unique ability to comprehend the context of sequential data such as sentences by examining the interconnections between the words. The primary purpose of developing transformers was to tackle the intricate task of sequence transduction, which involves converting input sequences into output sequences. An example of this would be translating text from one language to another. BiGAN. A novel computer vision architecture called BiGAN, which stands for Bidirectional Generative Adversarial Network, was also introduced in 2017. This AI model has the ability to generate realistic data by learning from examples. What sets BiGAN apart from traditional GANs is that it includes a generator that can also work in reverse, allowing it to map the data back to its original latent representation. This bidirectional process provides richer data representations and can be useful for unsupervised learning tasks in a variety of applications. Released in 2018, Revnet is a deep learning architecture in the computer vision category that has the unique ability to learn valuable representations while retaining all important information. It achieves this through a cascade of homeomorphic layers and an explicit inverse function, which enables it to be completely inverted without losing any essential data. This approach is highly beneficial as it ensures that no crucial information is discarded during the learning process, making it a promising tool for a variety of CV. StyleGAN. A breakthrough in computer vision called StyleGAN was also introduced in 2018. It is a type of GAN that has the impressive ability to generate high-quality images that are incredibly lifelike. StyleGAN operates by adding specific details to the image in stages, with a focus on particular areas such as facial features or hair color, while avoiding any impact on other parts. Additionally, one can alter the characteristics of the final image by manipulating inputs such as style vectors and noise. This innovative approach has the potential for many exciting applications in the field of computer vision. ELMO. ELMO is a framework for natural language processing released in 2018 that utilizes a two-layer bidirectional language model to produce word vectors. Unlike traditional word embeddings that only consider the individual word, ELMO embeddings take into account the entire sentence in which the word appears. This allows ELMO to capture the meaning of a word in the context of the sentence, resulting in unique embeddings for the same word used in different contexts. ELMO has revolutionized the field of NLP by providing more accurate and nuanced word representations. BERT. BERT, which was released in 2018, is a language representation model that can be pre-trained on vast amounts of text. What sets BERT apart is that it enables rapid training of various NLP models in just 30 minutes. Once trained, these models can be applied to other NLP tasks, including sentiment analysis. This groundbreaking framework has transformed the field of natural language processing by drastically reducing the time and resources required for model development and improving the accuracy of NLP models. GPT-2. GPT-2 is a transformer-based language model released in 2019, boasting an impressive 1.5 billion parameters trained on a vast dataset of 8 million web pages. By predicting the next word based on the preceding words, GPT-2 can generate high-quality synthetic text samples. What sets GPT-2 apart is its ability to learn various language tasks, including question, answering, and summarization from raw text without any task-specific training data. This highlights the potential of unsupervised techniques in natural language processing. GPT-2 has revolutionized the field of NLP by demonstrating the ability of language models to perform a wide range of tasks with remarkable accuracy. Context-Aware Visual Policy, or CAVP. CAVP is another network developed in 2019 for generating fine-grained image-to-language captions, including image sentences and paragraphs. This network is specifically designed to attend to complex visual compositions over time using previous visual attention as context. By doing so, it captures important visual context that traditional models may overlook. This innovative approach to image captioning has opened up new possibilities in the field of vision language, enabling more accurate and nuanced descriptions of visual content. Dynamic Memory Generative Adversarial Network, or DM-GAN. DM-GAN, also released in 2019, is a cutting-edge method for generating high-quality images from text descriptions. This technique overcomes the limitations of existing networks by incorporating a dynamic memory module that refines image contents when the initial image is not accurately generated. By doing so, Dynamic Memory GAN is able to produce more visually pleasing and realistic images than previous methods. This innovative approach has significantly advanced the field of vision language by providing a more effective means of generating images from textual descriptions. BigBiGAN. Introduced in 2019, BigBiGAN is another computer vision framework, an extension of the BigGAN architecture that is specifically designed for image generation and representation learning. BigBiGAN surpasses previous approaches by achieving state-of-the-art results in unsupervised representation learning on ImageNet and unconditional image generation. This breakthrough has propelled the field of computer vision forward by providing a more effective means of generating and learning representations of images. Momentum Contrast, or MOCO. MOCO is a cutting-edge unsupervised learning technique that falls under the category of computer vision. Its approach involves creating a dynamic dictionary by utilizing a queue and moving average encoder. By doing so, MOCO enables contrastive unsupervised learning, which translates to exceptional performance in tasks like classification. Additionally, MOCO has proven to be highly effective in downstream tasks such as detection and segmentation. Overall, MOCO's innovative methodology and impressive results have positioned it as a leading contender in the field of computer vision. VisualBert. VisualBert, introduced in 2019, categorized under Vision Language Model, is a powerful framework that enables computers to comprehend both language and images simultaneously. The framework utilizes self-attention to match significant sections of a sentence with the corresponding parts of an image. VisualBert has demonstrated excellent performance across various tasks, including answering questions related to images and generating textual descriptions of them. Overall, VisualBert's ability to integrate language and image understanding has positioned it as a valuable tool in the field of computer vision. Vision and Language BERT, or VilBERT. VilBERT was introduced in 2019 as a vision language model. It is a sophisticated computer model that enables the comprehension of both language and images. This framework achieves this by utilizing coattentional transformer layers that process visual and textual information separately before combining them to generate predictions. VilBERT has been trained on a vast dataset of image captions, making it highly effective in various tasks such as answering questions related to images, interpreting common sense, identifying specific objects within an image, and generating textual descriptions of images. Overall, VilBERT's impressive performance in these areas has made it a valuable tool in the field of computer vision. Universal Image Text Representation, or UniTER. UniTER is another cutting-edge computer vision language model that was introduced in 2019. The model has been trained using vast datasets of images and text, employing various pre-training tasks such as masked language modeling and image-text matching. UniTER has demonstrated superior performance compared to previous models across multiple tasks, including answering questions related to images, identifying specific objects within an image, and interpreting common sense. The model has achieved state-of-the-art results across 6 different vision and language tasks, cementing its position as a leading contender in the field of computer vision. BART, a pre-training model introduced in 2019 under the category of natural language processing, is a sequence-to-sequence model that employs a denoising autoencoder technique. This approach involves corrupting the text and then having the model reconstructed. BART's architecture is based on the transformer model, features bidirectional encoding and left-to-right decoding, making it a generalized version of both BERT and GPT. The model has proven to be highly effective in tasks such as text generation and comprehension, achieving state-of-the-art results in various summarization, question answering, and dialogue tasks. Overall, BART's innovative architecture and superior performance make it a valuable tool in the field of natural language processing. GPT-3. In 2020, OpenAI introduced GPT-3, a remarkable neural network that falls under the category of natural language processing. The model is capable of generating a vast array of text using internet data and is currently one of the largest language models in existence, boasting over 175 billion parameters. With this expansive knowledge base, GPT-3 can produce highly convincing and sophisticated text with minimal input, surpassing the capabilities of previous language models. Overall, GPT-3's impressive performance and massive scale have positioned it as a significant breakthrough in the field of natural language processing. T5. T5 is a cutting-edge transformer-based architecture designed for natural language processing tasks, which was released in 2020. It utilizes a text-to-text approach that allows it to handle a range of tasks including question answering, translation, and classification. This approach involves training the model to generate target text by providing input text specific to each task. By doing so, T5 achieves a more cohesive and streamlined approach to NLP as it uses the same model, loss function, and hyperparameters across all tasks. Diffusion Probabilistic Models, or DDPM. Diffusion Probabilistic Model is a novel computer vision technique released in 2020. It's a latent variable model that is inspired by non-equilibrium thermodynamics. This model is capable of generating high-quality images through a process known as lossy decompression. DDPMs utilize advanced algorithms to reconstruct images with remarkable fidelity, producing output that is virtually indistinguishable from real-world photographs. By harnessing the principles of thermodynamics, DDPMs offer a unique and highly effective approach to image generation in the field of computer vision. Vision Transformer, or VIT. The Vision Transformer is an advanced computer vision model that was first introduced in 2021. This model employs a similar architecture as transformers, which were originally designed for text-based tasks. The VIT model processes images by breaking them down into smaller segments called image patches, and then predicts the class labels for each patch. By utilizing this approach, the VIT model is capable of producing remarkable results, even outperforming traditional convolutional neural networks, or CNNs, while using fewer computational resources. The VIT's innovative design and methodology make it a promising candidate for a wide range of computer vision applications. CLIP. CLIP, a state-of-the-art neural network developed by OpenAI in 2021, is a revolutionary tool that combines vision and language to learn visual concepts quickly and efficiently. By utilizing natural language supervision, CLIP can recognize visual categories with remarkable accuracy. This allows the model to be applied to a variety of visual classification benchmarks similar to the zero-shot capabilities of GPT-2 and GPT-3. With its cutting-edge design and sophisticated technology, CLIP represents a major breakthrough in the field of vision-language integration and holds great promise for a wide range of applications. LBAF. LBAF is another innovative vision and language representation learning approach that was introduced in 2021. This technique utilizes a process called cross-modal attention to align image and text representations, resulting in more grounded and accurate representation learning. By applying this approach, LBAF achieves impressive results in multiple vision language tasks, including image text retrieval, visual question answering, or VQ-VAE, and natural language for visual reasoning 2, or NLVR2. LBAF's cutting-edge design and advanced methodology make it a powerful tool for vision language integration and represent a major step forward in the field of computer vision. Vector Quantized Generative Adversarial Network, or VQ-GAN. VQ-GAN is an advanced vision language model that was developed in 2021. It is a modified version of VQ-VAE that employs a discriminator and perpetual loss to maintain high perceptual quality even at a higher compression rate. To generate high-resolution images, VQ-GAN utilizes a patchwise approach and restricts the image length to a manageable size during training. With its sophisticated design and advanced technology, VQ-GAN represents a significant advancement in the field of computer vision and language, offering a powerful tool for generating high-quality images while compressing data effectively. DALL-E. DALL-E, released in 2021, is specifically designed to generate images based on textual descriptions using an extensive dataset of text-image pairs. With a staggering 12 billion parameters, DALL-E has demonstrated remarkable abilities, including creating anthropomorphic versions of animals and objects, seamlessly blending unrelated concepts, rendering text, and manipulating existing images in diverse ways. DALL-E's cutting-edge design and powerful technology make it a major breakthrough in the field of vision-language integration with significant implications for a wide range of applications. BLIP. BLIP is another cutting-edge vision-language pre-training framework that was introduced in 2022. It has been demonstrated to achieve state-of-the-art results on a variety of vision-language tasks such as image text retrieval, image captioning, and visual question answering. Additionally, BLIP is highly transferable to both understanding and generation-based tasks and effectively utilizes noisy web data by bootstrapping the captions. With its advanced technology and superior performance, BLIP represents a major breakthrough in the field of vision-language integration, offering a powerful tool for natural language understanding and generation from visual data. DALL-E 2. DALL-E 2 is a highly advanced AI model that was released in 2022 by OpenAI. It utilizes a GPT-3 transformer model with over 10 billion parameters to generate images from textual descriptions. Thanks to its ability to accurately interpret natural language inputs, DALL-E 2 can produce images with significantly greater resolution and heightened realism compared to its predecessor, DALL-E. The model's state-of-the-art technology and impressive capabilities make it a major breakthrough in the field of vision-language integration, with vast potential for a wide range of practical applications. Open Pre-trained Transformers, or OPT. OPT is a suite of pre-trained transformer models that were released in 2022, specifically designed to facilitate access to large language models for researchers. These decoder-only models range from 125 million to 175 billion parameters, providing an alternative to more expensive models that can be difficult to replicate or access. In particular, OPT 175B has shown remarkable performance, comparable to that of GPT-3, while being developed with only 1/7 of the carbon footprint. This makes OPT a promising development for researchers seeking to utilize advanced NLP models in their work without incurring significant costs or environmental impact. Sparrow. In 2022, DeepMind launched Sparrow, a natural language model processing-powered dialogue agent designed to minimize the chances of providing harmful or inappropriate responses. Sparrow interacts with users in conversations, provides answers to their inquiries, and utilizes Google's search capabilities to find additional evidence and bolster its responses. Overall, Sparrow serves as a reliable and trustworthy virtual assistant that prioritizes user safety and accuracy in its communications. ChatGPT. Also in 2022, OpenAI introduced ChatGPT, a cutting-edge natural language processing technology that uses deep learning algorithms to produce human-like responses to user inquiries. ChatGPT is an open-source chatbot that harnesses the power of the GPT-3 language model, which has been extensively trained on a wide range of subjects. This allows ChatGPT to effectively answer questions, provide information, and even generate creative content on diverse topics. Additionally, ChatGPT is highly adaptable, effortlessly adjusting to different conversational styles and contexts, making it a friendly and engaging tool for discussing everything from current events and hobbies to personal interests. BLIP 2. BLIP 2 is an innovative pre-training approach designed recently to address the high computational expense associated with end-to-end training for large vision and language models. This technique leverages pre-trained image encoders and robust language models to bootstrap the process of vision-language pre-training using a lightweight querying transformer to facilitate this process efficiently. In short, BLIP 2 provides an effective and streamlined solution to the resource-intensive challenges that have traditionally plagued the field of vision-language modeling. GPT-4. Recently, OpenAI has launched GPT-4, which is the company's most advanced system to date. GPT-4 has been designed to generate responses that are not only more useful but also safer. With a broader general knowledge base and enhanced problem-solving abilities, GPT-4 is capable of tackling even the most challenging problems with greater accuracy. What's more, GPT-4 is more collaborative and creative than its predecessors. It can assist users in generating codes, writing on creative and technical tasks, and screenplay writing while adapting to a user's style. These improvements make GPT-4 a powerful tool for a wide range of applications. However, with great power comes great responsibility. As generative AI becomes more advanced, we must ensure that it's used ethically and responsibly. There's always the risk of biased or harmful content being generated, and we must address these issues as they arise. Well, that's it for today, guys. So how do you see this fascinating evolution of generative AI? Do share your thoughts with us in the comments below. Don't forget to like, subscribe, and hit the bell icon to keep watching more of such insightful and entertaining stuff. Time to bid adieu. Take care, friends. Goodbye.